Hi, hello. Well, that was an intro. If you want to find out some things about me, I've already been introduced, so you know some of those. So I'm part of the CSS working group. I'm an invited expert, so yes, I do work on CSS. I guess somebody has to. So what I have been working on for the last few years is CSS Grid layout. This is something I've cared about quite a lot because I thought it was about time that we had a good layout method for CSS. And when I saw it a few years ago, I saw a sort of early implementation in IE10. I was like, yeah, this is what we want. And so I've been kind of championing it ever since. And it's been really great because it got into all of our browsers earlier this year. So we've now got Grid in browsers. I'm sure a lot of you have had a look at it or at least heard things about it. So this talk really is going to be some of the kind of top questions that I've had asked about Grid that I hear and about some of the other specs that work with it. So the first question that I'm asked by pretty much everyone is, why do we need Grid? We've got Flexbox. Surely that is here to save the world and to do everything that we need doing. And defined in the spec is the reason why we have Grid as well as Flexbox. Because Flexbox is one-dimensional and Grid is two-dimensional. And a really simple demonstration of that is there's a flex layout. So that will grow and shrink to as many columns as sort of will fit into the browser. But when we've got fewer items in the last row there, they distribute space across the row because they're only working in one dimension. So space distribution happens on a row by row in this case, or a column by column basis. That's one-dimensional layout as a row or as a column, not both at once. We can do the same kind of layout with Grid. But in this case, we still have a flexible number of flexible columns, but you can see the items will line themselves up as a row and as a column at the same time. So that's the difference with Grid. It's two-dimensional, not one-dimensional. But there's something else as well. Grid works from the container in. And this makes it really different from everything else that has come before, because everything else we use to create something that's like a grid in CSS requires that you give the items in your layout a size. So that size means that it will sit in your layout and other things will sit next to it and things will sit below it and they'll all line up. You've given them a size. So this is a simplified float example. If you've used some kind of float-based grid framework, it does something like this. You're going to have row wrappers that force clearing. You're going to use percentages for columns and for gutters, so you're going to have to add that stuff up, either manually, in your SAS, using calc, whatever. You're going to have to do some math somewhere. And so we end up with this kind of thing. We have a row wrapper going around the different columns, and then we have to add up all the values in order to find out how big anything is. And if you get your sums right, things will line up, and it'll look like you've got a grid. But there isn't a grid. We've just made it look like a grid. We're doing the work there. And Flexbox-based grid frameworks, well, they exist too. And Flexbox does work on the container. You say display flex on a parent, and the child items become flex items. However, they don't really become a grid. You can sometimes make them look like a grid, and you make them look like a grid by adding sizes to the items. And so then they'll all line up and it will look like you've got a grid. But we usually end up needing to have row wrappers again to stop things ending up in the wrong place. And we'll make the row wrapper into a flex container. It's a bit better than using floats because we can use things like all the nice alignment properties. And we don't have to do clearing and so on. So it's a bit better than using floats. But we're still not using Flexbox for what it's really good at, and that's that kind of, here's a bunch of stuff, just space yourself out. When we're having to do the maths again ourselves, we're doing a lot of the work to make it look like a grid. So what about Grid? Well, here, Grid does the maths for us. So what we do here is we say, well, I'd like to have 12 columns, so I'm going to repeat something 12 times. I say 12 times, and here I'm saying min-max 0, 1 FR. I'll go into that in a little while. But we're basically going to get a 12-column grid, and we can have gaps for gutter tracks. And then if all I need to do on the actual items is say how many of those tracks they span. I don't have to deal with sizing information on the item. because grid layout sorts that out for me on the track level, which is really what you want if you're asking for a grid. So it's a very different concept. It's a different way of thinking about things. We're defining the size of our columns when we set up the tracks. We then tell the items just how many of those tracks to span. And there's a few ways to do that in grid layout. But the sizing typically comes from the container if you're building that kind of 12-column grid. And we don't have other things in CSS that behave like this. So those grid frameworks, things like Bootstrap and Foundation and so on, they're creating something that looks like a grid by controlling item size. Whereas grid layout, we're creating an actual grid and we're putting items onto it. But it's no wonder really that people are puzzled, and they keep sending me grid-based grid frameworks that have row wrappers and are essentially one-dimensional. And the reason that we created frameworks like that around the older layout methods is that we didn't want to be doing all that maths. So we had a framework, whether we created it ourselves or it was a third-party thing, and then we could just add a class to our items, and that would work out the sizing for us, which is sensible because we don't want to be having to work that stuff out all the time. But we don't need to do this with grid. And every single abstraction I have seen to date has not really added anything to grid layout. It's just tried to force it back into this sort of old-fashioned way of looking at layout, which is really because of our history and where we've come from. It's taking a bit of a mindset shift for people to start thinking about layout in a different way. And so sizing is the important thing with grid. Once we start looking at containers and saying, well, this is our grid container, how big are the tracks inside, we need new sizing constructs, because we're not just dealing with sizing an item and saying, well, how big am I and how do I fit next to all these other things? So we've got a whole bunch of new things for grid layout that don't really exist anywhere else. And you've already seen a couple of those in the code I've shown so far. There was that example of having as many columns as will fit into a container, and this uses two methods that are designed to work on grid containers to enable flexible sized tracks. So we've got this repeat statement. So this just says repeat the pattern that's inside the tracks. So that could be very simple. You could just say repeat 3 1FR or repeat 3 200 pixels would give you 3 200 pixel tracks. We're doing something slightly more complex here. We're using autofill. So this keyword says, please autofill as many tracks of this size as will fit into the container. And then we use min-max. And this is a really handy little function. I'll show you a few examples of it, because we're saying, I'd like my tracks to be a minimum of 200 pixels. Don't be smaller than 200 pixels, but as a maximum, be 1FR. So what's going to happen here is the browser is going to say, well, how many 200 pixel tracks can I fit into the container? Okay, I've got 4. Then I've got this little bit left over, because it's unlikely that we're going to have exactly the right amount of space for those tracks. And so because the max is 1FR, we distribute the rest, the bit that's left over, to all of the tracks. So there'll either be 200 pixels, or there'll be 200 pixels plus a little bit to make a flexible number of flexible tracks in the container. So that's a really useful function to create sort of as many tracks as will fit, but still keep things lined up in rows and in columns. So the FR unit that I've just shown you, this is a new thing. It's for grid layout, and we need it because we need to be able to say, well, how can we distribute the available space? I've got a bit of space in this grid container. I want X number of tracks, and I want them all to share this space. And we do that with the FR unit. So you can specify different values. So here I've said, I've got a column of 2FR, one of 1FR, another one of 1FR. So the available space in the grid container is separated into 4 parts. 2 parts are given to the first track, then 1 part, then 1 part. And that will give you something that looks a bit like this. So you can see that we've got this big track, which has got 2 fractions of space, and then 2 1-fraction tracks. Very usefully, you can mix, because we're sharing available space, you can mix fixed length units with your fraction units. So here I'm saying we've got a 1FR, and a 400 pixel track. And we've also got this gap which will be taken away as well. So we've got a bunch of space. The browser says, let's take away 400 pixels, take away the 20 pixels for the gaps, whatever's left over, 1FR, 1FR, 2 equal sized tracks. So if the browser window gets smaller or wider, or the available space gets smaller or wider, those 2 1FR tracks will grow and shrink, but our 400 pixel track will stay 400 pixels. And then back to that 12-column grid example, where I'm saying repeat 12, min, max 0, 1FR. So I'm saying a minimum of 0, they can collapse down to nothing if they really do go that small, a maximum of 1FR. So essentially, we'll get 12 1FR tracks, so 12 equal tracks. And we don't have to worry about the gutter sizing. We don't have to calculate that separately, because the browser will take away the pixel sizing used for the gutter before it distributes the space. And the big problem people have when they come to grid layout from anything else is they want to use percentages, because they're used to using percentages and doing all that maths themselves. Most of the time, if you're using a grid layout, you can replace your percentages with the FR unit. You'll get a far better result. About the only time you might want to be using percentages rather than the FR unit is if you've got items that are also laid out with, say, Flexbox, and you want to make sure that everything lines up together for some reason. You might want to use percentages in that case, so that you can use them in both layout methods. Just going back to min-max, because it's got sort of lots of uses in sizing tracks. Allowing us to set a minimum and a maximum size for tracks is pretty handy. We can make sure that tracks don't get too small. And it lets us create very precise-looking layouts that still have room to grow. Because the thing about the web is that we can design something which has perfectly pixel-sized tracks in it, but someone's going to come along to our CMS and enter something enormous where we didn't intend them to. And we need things to grow and sort of accept that that might happen. So here's a quick example. I was on Facebook, there's a little panel like this they use for images. It's quite a nice feature. And I wanted to do something like that, but have some text in there. So that's what I've got here. Different size photos arranged to make a neat looking grid. So that's the grid definition for the panel. So I've defined some column tracks. I've got a 2FR and a 3FR track there. And I've used grid auto rows with min-max 200 pixels, so a minimum of 200 pixels, and maximum of auto. So that grid auto rows, is basically grid will create tracks as more content comes in. Grid just creates some new tracks for us. They're going to be a minimum of 200 pixels tall, so they'll always be that size. But that auto means that they will grow to take whatever gets put into them. So if I highlight the row lines, you can see that here, it all fits in, because my content there is spanning 2 tracks, so it's got 400 pixels and it fits in there. We've got this second image there, also spans 2 tracks. So they're all coming out at that sort of 200 pixels that I wanted. But then if we add some more content to the intro box, you can see how the whole layout just expands. That entire row expands to take the extra content, but also the item next to it needs to grow in order that that sort of works right across the rows. It's this thing with grid layout. If you make one track bigger, it's going to have to affect the entire track. You can't just change one thing in that box. So here I'm using object fit so that my image will also grow and scale if it needs to grow to fit into that box. I can then use the same technique to add a caption. Now here I'm making the figure a 2-row track grid, showing that a grid item can also become a grid container itself. You can nest grids, you can make it grids all the way down. You could also pop a flex item inside if you wanted to. You can sort of nest all this stuff up. So here I'm making a 2-track grid, and the second row track is a minimum of 100 pixels tall and a maximum of auto, which lets me put captions in like that. And again, this is also showing another little feature of grid, that we can layer things up on the grid, and you would just use Z-index like you would with absolute positioning to control that stack. You can also see that things don't actually line up at the bottom there, and that's because those sort of subgrids, the nested grids, don't have any relationship to each other. They're just an internal grid, and I'll come back to that point in a minute. So sizing. That's really important, as we've seen. And so I wanted to continue a little bit with sizing, because we've already seen that content can help define the size of tracks. Although Grid works on the container, you can, by using auto, you can allow the content actually to define the size of the tracks. There's a few other ways to do that as well. What you do have to remember always is that any sizing definition is going to happen right across the track. So if you're saying this track needs to be big enough to fit the biggest thing, well, all of those cells in that track are going to have to be that size. So let's have a look at some new keywords defined to let us play around with track sizing. We've got min content, max content, and fit content. These are defined in the very difficult to say CSS intrinsic and extrinsic sizing module level 3. And this is one of the friends of Grid, really. We've got a bunch of different modules that all work together in CSS. Another module you'll come across is the box alignment module, which deals with all of the nice alignment features for Grid and Flexbox, and in the future, other layout methods too. So this sizing module is where certain bits of sizing are defined. So min content. So here I've used min content for my first track. And if you set a track to min content, the content will try and use all of the wrapping opportunities available to it. So what actually tends to happen is you get a track like this. So you can see that that text has wrapped everywhere it can. It's basically wrapped down to the size of the longest word, which is content. It's all sort of compressed down, and that's happened all the way down the track. So that's min content. And then we've got max content, which does what you'd imagine. It does the opposite. So it will try and be as big as it possibly can and not do that wrapping. So in this case, we get that. So it's gone as long as it can. So that's max content. And then we have something called fit content. And fit content, we pass in a value. This time I've passed in 200 pixels to my first track and my second track. And the track basically then acts like max content until it hits the size we've set, at which point it stops. So in Grid, we can have a column that grows until it hits that size specified in fit content. But if it's naturally narrower, it doesn't stretch out to that size. So both of those tracks are using fit content. The first has got a lot of content in, so it gets to that 200 pixel limit and stops. But the second one doesn't have a lot of content in, so it's smaller. So that's fit content, very basically, sort of in a nutshell. I could easily spend a whole talk just talking about sizing, but these are sort of things to start playing around with as they work in Grid, because there are certain creative possibilities, being able to start to create tracks according to the size of the things that are in them. Now, we can't talk about shiny new CSS without talking about old browsers, because if I don't talk about it, you'll come and ask me about it anyway. So Grid is in the latest versions of Firefox, Chrome, Safari, Opera. On October the 17th, I think, it will ship into the update for Edge. So we've got a really good support for Grid layout in modern browsers, but obviously we have some old browsers still kicking around. Not all of our customers and clients suddenly update to the new browsers. So what do we do about those? The nice thing about new specs is that they tend to define what happens if you overwrite older CSS with new CSS, and Grid and Flexbox can do this. So if you use float as a fallback, you can, so here we've got a div and we've said float left, and then we make its parent into a grid. So that floated item becomes a grid item, and the float no longer applies. It just goes away. Any sort of floating properties, they just go away. The same with clear. You might use inline block to get two things to sit next to each other in a layout. And again, if you said display inline block on a child item, and then you make its parent into a grid container, all the inline blockiness of it just goes away. So that means things like the fact that it respects white space and so on, that will just go away. You can carry on doing your grid thing. Display table cell, I think is going to be very, very handy to do layouts for older browsers and overwrite. So if you say display table cell on a child item, you can then use vertical align and so on, which is why people tend to use it. Then when you say display grid, it stops being a table cell. But importantly, all the anonymous boxes, so the sort of anonymous table row and table wrapper that get created when you use table cell, they're not generated. So you don't end up with anything weird that might then become a grid item or something that you weren't expecting. So you can just overwrite table cell. And the same with vertical align, which you can use with table cell and inline block. Once the thing becomes a grid item, that stops taking effect, so you can start using the box alignment properties instead. Other useful things. Multiple column layout. Quite a good fallback for certain grid layouts. If you've got something that's like a bunch of cards all being laid out, you could always use multi-col instead of grid. So then your column count or column width properties, if it then becomes a grid, they're just ignored. They don't take effect anymore. And you could even use flexbox as a fallback for grid. And obviously, if something's a flex item and then becomes a grid item, any flex properties will just be ignored on that item. And that's quite a handy fallback. So obviously, flexbox has got better support at this point than grid has. So a lot of the time, you can create fallbacks by just using the way that CSS works. As long as you do things in the right order, browsers that understand the first instruction but don't understand grid layout will do the first thing and then won't do the grid thing. They'll just ignore it because browsers ignore CSS they don't understand. And browsers that do support grid will do the grid thing. However, I'm sure you can see there's a bit of a problem there because there are some things that are going to be understood by older browsers and newer browsers, and there's going to be a problem. This is a very simple example of that. If I've got a floated item and I've had to give it a width, because that's what we do in old layouts, I've given it a width to say, well, I want you to be about 1/3 of the available space. Once that item becomes a grid item, the float is ignored, but the width isn't. So the item now becomes 1/3 of the width of that grid track and becomes little and tiny and not what we wanted at all. But it's okay, because CSS fixed that problem as well with feature queries, which need to become your new best friend. Feature queries have excellent browser support, and it doesn't matter about the older browsers that don't support them, because what we typically are doing is writing old CSS, and then we write the new CSS. So I need to test for the browser, and say, do you support display grid? And if it does, I can set that width back to auto. But what this all means is you do need to understand CSS to get this working. So it's really important to actually go back and make sure you understand how the cascade works, how to structure things. And then you can get away with using very minimal fallbacks and being able to use all the new features of CSS, grid being one of them. And really, the actual fundamentals of CSS haven't changed all that much. And we've got all this new stuff, but they all still sit on top of a stack that's been pretty much the same since CSS began. Now, very quickly, I wanted to talk about some things that we haven't solved yet. Now, I showed you that issue of nesting one grid inside another and how things didn't line up in the nested grid. So we've got a layout like this. This is a layout that came from a designer who believes that content comes out of the CMS with perfect line lengths, and it looks very neat like this. So we can create a grid very easily for this lovely, neat layout. We can just say, well, let's have 3 columns of 1 FR each, but then the data comes out of the CMS, and it looks like that. And then the designer says, but I want those to line up. I want all those things to line up. I want the titles to line up. I want the footers to line up. And we can't do that because the internals aren't participating in the grid layout. About the best we can do is make each of those items either a grid or a flex item, and then we can push the footer down to the bottom, which is a bit better, but it's not really lined up. And we've still got a footer that's too tall and a title that's too tall, and it looks a bit messy. What we really need is to be able to create a subgrid inside each card that actually understands that it's part of the overall layout with 4 tracks like this. And we'd say, well, so each row needs to make space for those tracks. So we say start on auto, span 4, display subgrid, which would give us something like this with all the elements participating in the grid layout. But this is all completely theoretical. There aren't implementations of this. That idea is the subgrid spec that was removed from level 1 and put in level 2 because we think it needs a bit more discussion. If you're interested, there are a bunch of links. I'll be showing these slides. You can have a look. And we'd be really interested at the CSS working group to know what you think about stuff like subgrid. And then masonry layout. This is probably the second question I get asked after why do we need grid at all, isn't this masonry? Can we do masonry with this? So masonry is this kind of layout that you see on things like Pinterest, where boxes kind of all arrange themselves nicely no matter how big they are. This looks a little bit like that, but I've positioned the items here. The reason people think grid is masonry is because of this feature, grid layout auto placement. Basically, I can take a chunk of stuff, throw it at a grid, and grid will just lay it out for me. And I can set up some rules for types of boxes. So I can say, well, all landscape images, please span 2 tracks, and portrait ones just span 1. And grid will just lay that stuff out. We'll get something like this. Grid is staying here in document order and laying the items out and trying to find space for them. We can go a step further and set the value of grid auto flow to dense. And then grid will actually take things out of DOM order and backfill the gaps, which is pretty neat, but it's still not masonry. This is still a strict grid with rows and columns. We've also got this issue of having taken stuff out of document order, which may be a problem if people are sort of tabbing around things that can be selected. Masonry looks a bit more like this. Items stay in document order, we work across the row, but they'll kind of shift themselves up into spaces that are left to get this nice, neat layout. To do this with grid, you have to have lots of row tracks available and basically position your items using line-based positioning. You're currently closer to masonry with something like multiple column layout. However, it's certainly come up, it's mentioned in the sort of rough level 2 spec. I've written about it, there's an issue on the CSS Working Group repository about masonry. Again, it's something that you can go, if you've ever written that kind of plugin in JavaScript, come and talk to the CSS Working Group about it and the sort of things you need. An awful lot of stuff that is happening in CSS comes from the JavaScript community, comes from things that people are doing in JavaScript that we can possibly do in a more performant way natively in CSS. So please, if you've got ideas or you think things would be better off done in the browser, come and talk to us about it. As JavaScript developers, you've got an awful lot of experience of doing this kind of user interface stuff that we'd really like to know about in the working group. And when it comes to grid and these newer layout methods, remember, this is new to all of us. I've been playing with the spec for a very long time, but I've only been able to use this stuff in production since March, when it all shipped into browsers, and I'm still finding out things that are new about it or that I didn't quite expect. So do play with it and understand that all of us are still learning, and we'll be very interested to hear what you think or what you're falling over and stumbling on, because it may be that maybe the spec's not clear or we need to write some resources to help. And so if you come across problems when you're working with grid or any of these specs, in fact any CSS spec, write about it. Write about the stuff, come and tell people, tell us at the CSS Working Group, all of the issues for CSS are now on GitHub, so it's as simple as going and raising an issue and saying, why does CSS do this, or why doesn't it do that, or it would be really great if the spec worked like this, you can do that. The web is your platform to create on. And so we want to hear what you're doing and what isn't working well and what problems you need to solve, because then we can try and make it better for everyone. And if you've not experimented with grid yet, gridbyexample.com is a site I put together as I learned the spec, and there's a whole bunch of stuff. There's loads of patterns, there's small examples, there's a great big video tutorial, lots of ways to learn grid. I also wrote a bunch of stuff for MDN, so you can have a look there. And I'm also collecting interop issues. If you come across a grid bug, I would like to see it, because if we can get them listed, we can get tests written for them, and we can hopefully get them fixed. And if all this layout stuff is interesting to you, I've got a new book, it's number 22 for me, out on October the 10th from A Book Apart. So thank you very much for listening to the CSS person at the JavaScript conference. My slides and resources are here. Thank you.